Okay, so today I'm going to be giving a little introduction into radians. Now these are another way to measure angles around the circle. So you're probably familiar with using degrees, and you'd have 360 degrees around the circle. Radians are a little bit different. In a sense, they're more natural because we aren't using an arbitrary number. So why do you use 360 degrees? Why not 400 or 1000? So radians kind of takes away that uncertainty, and we're going to see how it's defined. So this angle here, theta, is equal to 1 radian, theta equals 1 radian, when the arc length, so this distance here, around the circle, subtended at these 2 points, is equal to exactly 1 radius of the circle. So this length is 1 radius, this is 1 radius, and this arc length is 1 radius. So that's when we have 1 radian. And typically you use this notation, so 1, and then we have this little c, or you might also see 1 rad. That's also quite common. Okay, so we're going to see in future videos why radians are particularly nice, because they lead to nicer formulae, like the length, the arc length of circles and the areas of sectors in circles. But for now, let's just focus on converting between radians and degrees. So let's just get a feel for how these work. So first off, let's think of a full revolution of a circle. So if I just draw a rough sketch, and this is the radius, what is the angle when we go around the circle a full turn? So we know we're ready for degrees, that's just 360 degrees. But what about in radians? So for this we kind of need to go back to the definition of a radian. So remember, the angle is 1 radian when the arc length is r. So we want to work out the angle of the full circle, and for that we need to take the full arc length of a circle, which is just the circumference. So remember that the formula for a circumference of a circle, for any circle, this is 2 pi r. And since 1 radian is when the arc length is r, we need to divide this formula by r to get the number of radians. So this tells us that 360 degrees is equal to 2 pi radians. And so it's useful just to get the smallest quantity. So if we just divide by each side to get, so first off, let's look at 1 degree. This would be useful to know. So we just divide by 360 on both sides, and so 2 pi over 360 in radians, and then the 2 kind of simplifies and we get pi over 180 radians. So 1 degree is equal to pi over 180 radians. And similarly, to get 1 radian, we just divide by 2 pi. So 1 radian equals 360 over 2 pi radians, and we can just cancel the 2, so we get 180 over pi degrees. So this actually gives us a way to convert between degrees and radians. So if I just write here, if we have a quantity in degrees and we want to get to radians, how do we get there? So what's the conversion ratio? And it's given by this. So 1 degree is pi over 180 radians. So we just need to multiply by pi over 180. And similarly, the other way around, if we have radians and we want to go to degrees, then we use the second conversion. So we just multiply by 180 divided by pi. And this gives us a way of converting between these two quantities. So now we're just going to look at a few more examples just to get a feel for this. Okay, so let's look at these examples. We want to convert these angles in degrees into radians. And we're going to use these conversion rates. So these are really useful angles to know because we're always using, these are full revolutions, half revolutions, quarter and an eighth. And it'd be good to have these quantities in radians. So let's just use these conversion ratios. So 360 degrees, to get this in terms of radians, we need to multiply by pi over 180. And so 360 times pi over 180, then this comes out to be 2 pi, which is something we saw already. But let's do 180 degrees now. We can use this conversion ratio again, or we can just divide the above quantity by 2. So this is going to be pi radians. So a half revolution of a circle, this corresponds to rotating by pi radians. So that's really useful to know. And then 90 degrees, this is going to be pi divided by 2 radians. And then 45 degrees is pi over 4. Okay, so let's do some examples going the other way around. So we've looked at degrees to radians. Let's try and get from radians to degrees. If I just write these examples out, pi over 6, pi over 3, and let's do pi over 18. So first off, to get from pi over 6 radians to degrees, we use this conversion ratio, so we multiply by 180 divided by pi. And so the pi's cancel, which is quite nice, and then we have 180 divided by 6, which comes out to be 30 degrees. So we can do the same here. Pi over 3 is actually 2 times pi over 6, so we can just double what we had above. So this is going to be 60 degrees. And finally, for pi over 18, let's just use the formula again. So pi over 18, and we multiply this by 180 divided by pi. This is nice because pi's cancel, and then we get 180 divided by 18, which comes out to be 10 degrees. So this video was really just to provide an introduction of radians and to get used to converting between them. In the next few videos, we're going to look at some nice formula for arc length and areas, and we're going to see that radians are really useful because they lead to nicer formula. So we're going to see that in a bit.